My name is Andrew Auger, and this is my demonstration project for MAE 535. For my topic of electro-rheological fluids, I will be showing the unique properties of these fluids that are prevalent only when in an electric field. So, rheology is a study of materials with both solid and liquid characteristics. Electro-rheological fluids are composed of dielectric solid particles in an electrically insulated fluid, or in other words, a conductor coated in an insulator. So for my electro-rheological fluid, I'll be making a mixture of 50% cornstarch and 50% vegetable oil. Mixed together, it should look a lot like this. Just a clumpy, kind of yellowish, whitish mix. But it's mostly fluid, like when you spin it, when you move it around, and just goes around like normal fluid. For this project, I have a pre-made same mix, 50-50, but I threw in some coloring, just food coloring, so you can see it better. And then, so for the electrical field, I'll be using a balloon. For this balloon, you rub it against your hair, or cloth, or fur of any sorts, and it gains, it takes a lot of the electrons from wherever you rub it against, and so it gets negatively charged. So the electrical field will be going into the balloon, because it goes into the negative charge. When the field is applied, the dielectric particles form chains in the direction of the field. Basically, the fluid clumps up and becomes a solid going in the direction of the field. The fluid, when it becomes solid, it acts like a big plastic and gains a yield strength, directly influenced by the field intensity. So the stronger the field intensity, the stronger the electric field going out, the higher the yield strength. So the yield strength, it basically stays solid like a big plastic until the shear stress acting on it overcomes or goes over the yield strength from the electric field. So basically, when I'll be pouring this out, it'll be going up into the balloon, and then once it reaches a certain amount, the gravity and the force that goes out will overcome it, and then it will just return to regular fluid and drip down into the cup. So to charge this up, you just rub it against your head. And so it's got a pretty big charge right now, or well, big for a balloon. Alright, and let's put a cup down here so it doesn't go anywhere. Alright, so when pouring the fluid, initially it will look like just a regular fluid dripping down, but as I'm pouring it, you can see it moving a lot just straight towards the balloon. And that curve, it curves out just straight out. And then, well, now it's all over the balloon because I believe that adding the food coloring made it a lot stronger than without the food coloring. So you can see right there, it gains the yield strength and charges up. Basically, it goes along the field into the balloon. So you can see that the balloon, you can confirm that the balloon is negatively charged, and that the field will go from positive to negative because the flow is going up into the negative. If it was positively charged, it would likely push the fluid far away. So basically, this demonstration has showed that you can visualize an electrical field with the use of this fluid and a charge, and it has also shown the properties of the yield strengths and how the electric field, making the yield strength greater, makes it solid until gravity takes course and overcomes it, and then it goes back to a fluid.